All right, with a worded question, what's the first thing that we should do? Thanks, kids. Right, draw it out, and we don't need all of the palaver that we've got there. So if I was to draw this out, we've got the goals, we've got the player over there, and I'm going to put my information on. So when a player is 26 metres from one goal post and 23 from the other, so I've got 23, 26. I'm not overly impressed with my diagram because what does it look like? It looks like a right angle triangle, but as long as I don't stick the right angle there, then I won't do it. But no, I will redo it. That's naughty. Bad, Ange. There we go. That's a bit better. Okay, so we've got 23 and 5 metres wide. Obviously not to scale. What is the angle of view of the goals that the player sees? So where am I putting my theta? Right. Now, your textbook rearranged this formula for you beautifully. I can't stand it. I like just to use my cosine rule right from the get-go, and I sub in and I rearrange it myself. Why am I going the cosine rule and not the sine rule? I don't have a known pair. Well done. And all 3 lengths? That's leading me towards my cosine. Is this big enough for people to see, by the by? Right, so I sub in, and your main thing is that, am I going to sub in 26 squared equals 5 squared equals or 23 squared equals? 5 squared. You're answering all of your questions. What was wrong with this? So we pop that in. And your job is to now get theta by itself. So you're rocking the algebra. And that's why I don't like it when they've already given you the formula rearranged. It has to be you do it yourself, because this, I should rock up the, let's have a look. Just so you know why I do the things that I do. If we have a look, did I put it on here? Okay, so here's your Year 12 formula sheet, which is what, oh, that's the specialist one. Oh well, that'll do. This is on your methods as well, but you can see, right, you can see they give you some trig stuff there, and they haven't got your cosine rule rearranged to have the angle by itself. Okay, so that's why I think we should be able to do this. So we're going to get rid of this plus 23 squared and the take 26 squared. And to get rid of all of that times, we will divide. And to get theta by yourself, you will just inverse. Are you helping him with the book there? And we should get the right answer. Is that the only way to do it? Do you say no because I've asked it in that way, or because you know that there's another way? So at this point here, I could have rearranged, right, and brought this minus all over the other side. So I could have said that's 2. So positive 2 because it comes over. 2 times 23 times 26 times cos theta, and that would equal 23 squared plus 26 squared, and you're taking the 5 squared, and that's why it's a little, that's probably going to look more like the formula that the book has got. It's how they've rearranged it. I just tend to find when students use that formula, they don't have the right values in. That's just my take on life. So, a tower, 42 metres high, stands on top of a hill. So now you'll be wondering, why am I a maths teacher and not an art teacher? There's my hill. Pretty impressive. 42 meters. Here's my tower. From a point some distance from the base of the hill, so some distance, base of the hill, the angle of elevation to the top of the tower, right? Top of the tower is 13.2. Happy so far? I wouldn't draw it down just yet, just in case I stuff up. Don't have that much blind faith in me. And the angle of elevation to the bottom of the tower is 8.3. So what's going on there? The bottom of the tower? That's a bit. So that's 8.3. Find the height of the hill. So we want to find would you agree? Okay, so we're going to assume, and we're allowed to assume, that the actual height of the hill is that vertical height. We've got an angle if we're looking at that right angle triangle, so that's awesome. But unfortunately, that's all we have. So you have to make a decision and go, well, is it going to be easier to find this length, or shall we go for that bottom length? Which one do you think is our first attack to try and get it? This one or this one? Why the bottom one? Yeah, because that's what we want. Unfortunately, if we look at this triangle here, all we've got is one angle. If we look at the bigger one, well, yes, we've got one angle. We don't even have a whole length. So that means we tried to do that. It's not going to work. So what we will now try is we are going to try and get that one there. It's a little bit better because if I look at that triangle, that's 42. Do you agree? I want to find that length. Do I have any other information? I really would like if I could, haven't got the length, but I reckon, can you put your heads together and see, is there any way I could get that angle? I've got two people that think, yes, I could get all 3, 4, yes. Okay, so absolutely, this angle here is going to be 180, take 90, take, do I have to add them together? That whole one is 13.2. So this angle here is going to be 90 minus 13.2. Agreed? And what about this angle here? Yes, Ed? 13.2 minus 8.3. So what you now have is you are going to have an angle and its opposite length. So you've got a known pair. Do we agree? Agree? Oh. And here's the length that I want, and I now have its opposite angle. Do we agree? So we should be able to now go ahead and find this length, which is the y, and then you've got an angle, and you should be able to find x. Agreed? Give it a go and I'll come around. I won't actually do the questions, but I'll give you a nudge.